And if you click on the background information, this is the experiment that itself, as found in your lab manual. The first part is always the experiment itself based on the lab manual. Okay, so I just took pages since I'm the author, create a PDF file, and that's where it is. That way you don't have to keep referring to the lab manual. This is the data that you guys are going to be using for this activity. Okay, so if you click on that, this is the data. It's actually an Excel spreadsheet that I converted to a PDF file. The first part is the intermolecular force. If you scroll down, the second part is the pH of acids and base. And the third part is the absorbance of the cobalt chloride experiment. So part 1, part 2, part 3, that's the data. You find it on this tab right here. The PowerPoint is what I'm going to show you shortly. And then the video is actually me doing the experiment. Okay, so let me change and go back. I'll come back to that PowerPoint. I want to show you under activity 4, you'll see that it's broken down to intermolecular forces of alcohol. That's the 21st. And then the 28th, which is continue with activity 4. That date is incorrect because this should be next week, Wednesday. That's an incorrect date. So we've already looked at the background. Let's take a look at this right here. Because what I just introduced on this page right here, this is just the worksheet and the data sheet, but right here is guidelines on how to write your intro and the procedures. Okay, and even though this is not an experiment, we can treat it like an experiment. Okay, and remember that because we're not using lab archives, you guys are going to enter your intro and procedure in Canvas. You're going to enter your data and observation in Canvas, and you're going to enter your post-lab write-up in Canvas. But what I want to do is, based on the grading criteria that I use for this class, I want to guide you as to what you should include in this particular activity, which we are treating as an experiment. This is not a lot of points, but I want to make sure that you guys understand what should be included in a regular experiment. So here is a guideline for 4A. This is the intermolecular forces of alcohol, the date and the course number, and the title of the experiment. Okay, and then you don't have to put boxes. I just put boxes here to show you the different sections. This whole section is the intro and procedure. Under objective in 50 words or less, write the objective of this experiment, write what is to be investigated, the chemicals to be studied, and the experimental techniques to be used. If you can write that, then it tells the audience right away what's involved in this particular experiment. The background information should give you enough information to bring the readers up to speed. So look up the concept of intermolecular force and define it here, because that's the key in this particular experiment. You're determining the intermolecular force strength of these alcohol. So you need to define it. Otherwise, a reader who doesn't know what IMF stands for, they're going to be lost. Discuss how properties of matter is manifested through the intermolecular forces. How are boiling points and heats of vaporization especially, because that's actually what we are looking at in this lab, relates to intermolecular force. Describe why one chemical might have a stronger intermolecular force versus another, especially based on its structural properties. So this is what I want in terms of the background. You're bringing up the reader to speed in terms of the theories that are involved in this experiment. Write about the probes to be used. The probes are just the instruments that we are using in this particular experiment. For example, you guys are going to be using the stainless steel temperature probe. And how is it used in this experiment? What is the difference between Vernier and Logger probe? Because that's the program and the hardware that you guys are using. So since this is the first time that it's being used, you need to make sure that you explain it to your audience. Discuss how does temperature drop reflect on rates of evaporation? How does the temperature change, or the drop in the temperature as something evaporates, relate to intermolecular force? Elaborate how rates of evaporation infers the strength of intermolecular force. Discuss what type of intermolecular force are available to alcohol. Now we are specific to the chemical, and um, predict which chemical among the series, methanol, ethanol, propanol, and butanol. Although we're just working with methanol and ethanol, propanol and butanol are extrapolated based on the data. So you should also mention that. We'll have which will have the strongest and which will have the weakest intermolecular force, and write the structure, Lewis structure, molar mass, and type of intermolecular force available for these chemicals. If you look at the worksheet, show you the worksheet, that's the data table that I asked you to complete right here. Okay, so you should mention it in your discussion. Now, I know it's overkill for a simple activity, but I want to set the stage so that you understand that when it comes to your experiment, that's the level of thoroughness that I want. Okay, I want to make sure that we're all on the same page as far as what type of details I'm looking for. For this, and then after giving the background, then you do the procedure. For this experiment, write an outline of each step. Remember I told you when we were talking about notebook that I don't really want words, I want more pictorial diagram. But for this particular experiment, since it's the first one, I want you to draw an outline and then draw an icon representing that particular sentence in the icon. That will basically train you to do a pictorial flowchart. For example, one of the steps is to wrap a piece of filter paper that's cut out in 2 by 5 centimeters around the thermistor. This temperature probe is also called a thermistor, and then secure by a rubber band. Okay, show how vernier is set up and the settings, and then this is the data table that's going to be put in. In terms of safety, this all the chemicals that will be used. The methanol and ethanols are going to be listed, are the main chemicals in this experiment. I forgot to put in here how they are to be handled. In this particular case, you place them in a test tube and you close them with a rubber stopper so it doesn't evaporate. Okay, you never handle it by hand. And then go to this page right here to find the SDS data for the 2 chemicals that you are using. And I just want a screenshot of the first page. The first page pretty much tells me everything I need to know about this chemical, and then I just paste it here. Do the same for ethanol. And then the last part is answer any pre-lab questions, if any. So that would be what you would write for the introduction of your experiment. Okay, now I haven't had time to do this yet, but the next thing I'm going to do is I'm going to give you a guideline of what to include in your data and observation. And then I'll also write up a guideline of what to write up in your post-lab write-up. Okay, and again, rather than you guys guessing what you think I want in there, I'm telling you what I want in there so that there's no second guessing. And if you do that, then I will wean you off these guidance eventually. And you guys can give me a very good write-up that will prepare you for organic chemistry. But I wanted to show you this because I want to give you the fundamental information that you will need so that there's no second guessing what I want in the write-up. Okay, so that's that. We're going to get to this in more details next week. Let me go back to module. Okay, and then the last thing I'm going to do is show you the video of this experiment. And I want to make some editorial comments, and then we're done. Okay. The only thing that's due is this Friday. That's the until date for activity 3. Of course, if you can do it tonight, then you get a bonus points. if you can complete it by tonight. So let me go back to activity number 4 under background information. Okay, under background information, you see this video. I'm just going to click on that. It's going to show you the video. I want a full screen video, so I'm just going to click on that, and then I'm going to start it up. At this point, you guys should see the full screen of this video, and then I'm just going to basically go through this. Read this introduction, because this is my PowerPoint. This one especially, because it pretty much tells the heart of what this experiment's about. You want to include this in your background information. These are the equipments that you guys are using: the computer, the temperature probe, and test tubes. This is what it will look like when you set it up if you were in lab. Okay, so here's me in fast, because I don't want you to just like sit there while I do this 3 or 4 times, because it was very difficult to put the filter paper on with that small rubber band, with that rubber gloves. Anyway, here it is. What I'm doing now is I turn on the instrument and I let it run so that it equilibrates at room temperature. Then I just took, let me go back. The neat thing about this is you can always go back. Okay, you notice that in this particular form right here, I'm going to stop. These temperature probes are either in ethanol and methanol. The orange is in ethanol, that's the red, and the blue is in methanol, that's the second one right here. And right now it's equilibrating at some temperature, sitting in there. I'm letting the experiment run. And then what I'm going to do is I'm going to let it equilibrate, and then I'm going to remove them. And as I remove them, now the alcohol are evaporating off these filter papers, and look at the temperature drop. Okay, one is dropping faster than the other. And what I want to record in the data is, this is the initial temperature up here. You want to find the lowest temperature it reaches, because eventually it'll start going back up again. Okay, what I did was I just increased the time. So I could stop this experiment right here because I'm pretty much done. And what I did, of course, was I went back, took those things, put it back into the alcohol. And that's why it's gone up. It's gone to that temperature again. And then I'm going to do a second trial. And what I'm doing is I'm just looking at the temperature difference between the lowest and where I start. And here it goes again. Okay. So that's the data that you guys are recording for this experiment right here. I'm going to fast forward this. And here is a close-up. And this is actually Logger Pro, because the computer is actually recording this. And so what I did was I just took the computer, because you can run it as a movie, and I'm basically going to run it again. That way you guys can see in real time what the temperature drop is, and you have better resolution here. Okay, now you notice this is not moving, and the reason why this is not moving is because this is at the 150, 162. The data points is all the way on top. See how that's moving right there? Okay, that's because it's being collected, but your frame is between 150 and 162 in terms of this. That's why it's not shown. Anyway, that's the data for this particular experiment. It's also in the data that you can download. This is the second part. This is the acid-base property of household chemicals. Again, these are the different chemicals that you guys will be testing. These are the probes, and this is what it looks like. I have a bunch of test tubes here, 1 through 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. There's a missing bottle in here somewhere. 1, 2, 3, 4, 5, 6. Right here. Yeah, vinegars to the left that you don't see right here. Okay. Vinegar is all the way to the left. That's why it's not shown in this picture. But this is how you would set up this experiment if you were doing it. You have the solutions, and then you have litmus paper, and you have something called hydroion papers. Hydroion papers will change color depending on the pH. So what happens first? Well, we're just going to test each one of these individually. Well, before we do that, we calibrate the pH probe. We gotta calibrate it to pH 4 and pH 10. Okay, and pH 10, and then we test with pH 7. So that first part is just the calibration of the probe. Here you can see that, I apologize, that's sort of blurry, but that was 4 and that was 10. That's 10. Now we clean it and then we put in pH 7, make sure it's reading correctly, within plus or minus 0.1. Okay, so this one's actually pretty good. It's within 0.001. So once we do that, now we can test these solutions. And I put an inset of the hydroion paper. And the reason why I did that is because notice that I am touching a glass stirring rod to each of the solutions and then wetting the test paper. And when you wet it down, you need to make sure that you can do a reference. And colors may vary depending on your monitor, but they should all vary evenly. That's why I have that illustration of the different colors shown here. And now you could pretty much estimate just based on the litmus paper. Notice that there is red litmus and blue litmus, and then hydroion. So red litmus and blue litmus will tell you whether it's acidic or basic. And then the hydroion will tell you approximately what the pH is. So I go through all 7 solutions. And now just based on the color, you should give an estimate of what the pH are for each one of these. First one is vinegar, second one's ammonia, third one is lemon juice, fourth one is 7-Up, fifth one, well, you can see that. Now I'm putting in here some universal indicator. And the universal indicator legend is to the right. Okay. So I'm taking the whole solution now, I'm putting universal indicator. And again, it'll give you some sort of pH range. And I'm putting another drop or 2 to ammonia. And you guys will use the legend right here to the right to give an approximate pH of what that is. I'm going to fast forward. Okay. Now I'm going to take the pH probe and put it in each of these solutions. And then I'm going to read the pH of each of these solutions. And I'm going to do it in triplicate. You always want to do things in triplicate, because if one of them is an error, then you have another 2 to kind of see whether it's the error is correct or in the high side, low side, or just to confirm that it's correct. So that's the pH. Okay, you can see that whereas this experiment in the lab would probably take about, remember we're doing it over 2 days, so probably take about maybe 4 hours. This whole thing is done in 17 minutes. But you have a chance to go forward and backwards. Here's the pH of the different. This is series 1, series 2, series 3, series 4, 5, 6, 7. Okay, so these are the data set again doing it in triplicate. This is just doing it in fast forward. Wasn't really that quick in terms of doing this. Finally, the last one, and I'm going to stop there because I don't want to bore you guys to death. We'll talk about this next time. But Again, watch the video because it gives you an idea of how the data is collected. And here's the data right here. Okay, this is the data. This is the temperature, trial 1, trial 2, trial 3. This is the pH, 1, 2, and 3, 1, 2, and 3. These are the different trials. And then this is the last part, which we'll talk about next time.